Hello, my name is Andy. I'm one of the student workers here at Anderson Labs, and today I will be showing you how to 3D print. The guide for how to set up your print is located in workshop slides in the same Canvas page. The first step is to first put your name into the queue. The queue is also located on the Canvas page. After that, you will talk to the student worker at the front desk to check out your filament. The workhorse of our lab is the TAS 6. Every single semester, the Anderson Labs provide CSE students with 500 grams of free filament, including the summer. The main filament that we use is PLA, and we do reserve 2 other printers for other types of filament if you do decide to buy some yourself. Today we're going to go to the sample files tab inside the Canvas page. Then we are going to click on the dice, that is the sample we're going to be using today. After that downloads, we will go into files. Don't save it to the desktop because the desktop is a shared network. We're just going to drag it into documents. There it is in documents. Then we're going to go to the bottom left search bar, type in Cura and open it. It hasn't shown up, but it is where it says type here to search, and you just type Cura. When Cura comes up, we're going to go to the top left, click open file, and click on our dice. In our materials menu, we're going to choose PLA. You can either choose high temp PLA, PLA verbatim, or PLA Village Plastics. I personally prefer the verbatim setting. In profile, we're going to choose standard. You can choose high detail, but high detail does tend to fail more often. We're going to be in the recommend tab today. Infill is standard at 20%, and you have the option to generate support if needed. If you go to the layer view, you can see how the print is going to come out. And if you click generate support, you will be able to see that the support generates inside the dice. For our print today, this is optional, so we're just going to turn it off. Our next settings are the build plate adhesion. You can choose from a skirt, a brim, or a raft. With the brim, you can see that the bottom extends out. This helps the part stick to the bed. It is very useful for large parts. With a raft, you can see that it stands the part up. This provides more stability and also helps the part stick to the bed. As our dice is very simple, today we're just going to use a skirt. Next, we're going to click Save to File. Then we're going to choose our Documents folder again, just because it's the easiest one to get to. And then we're just going to click Save. You can rename it if you want. You can see down at the bottom, it tells you where it's saved and the name of it. Next, you're going to record the time and also the weight of your print to give to the student worker. Next, we're going to go back to Google Chrome, and we're going to go over to OctoPrint. The URL is me://.cscelabs.umn.edu. The numbers stand for the number of your printer. Today we're going to be using printer number 9. Next, you'll see the login. The username and password are student and makerspace respectively. There is no capital letters and there's no spaces. Then you're just going to click enter, and you should come over, and if you see the connect button, click the connect button. This will connect the website to the printer and allow you to upload. We're going to take our filament and we're going to put it onto the arm. String the filament through the tube located next to the side of the printer on the back, and we're just going to keep pushing until you see it come out the other side. Once the filament has come out the other side, we're going to put it in between 2 screws. There's a hole there. We'll just have to locate it by itself. You're going to push that latch up, push the wheel in, and then you're going to drop the latch over. There should be spring tension, and if there's not enough spring tension, you should turn the wheels righty-tighty, lefty-loosey. Without the spring tension, the print will fail, and that is our most common cause of failure. Next, we're going to turn the printer on, if it is not already on. We're going to click the middle button. We're going to go to temperature, choose nozzle, and then we're going to turn the nozzle up to anywhere between 200 and 215. Next, we're going to go back to main, and we're going to go to movement. We're going to choose move axis, and we're going to choose move Z. Move Z helps determine the height of the printer. If the printer is still too low, we're going to turn move Z up and have the printer head raise. This gives you room to work with the nozzle as the filament gets extruded. Just checking to make sure there's enough room to actually move your hands underneath there. I will show you how to use the move Z. You just click on it, click move axis, 0.1, and just push it up, and the nozzle should rise. Next, we can check the temperature by going back to main and info screen, and you can see it on the top left corner. You want to make sure it's at least 180 before you try extruding. You can go to movement, move axis, extruder, move 0.1, and you can turn that up. You can turn it as much as you want, just so that the filament starts flowing out. If you want to stop it, you can just simply turn off the printer. Here you can see that the filament is extruding out the front of the nozzle due to the extruder setting. And you want to make sure that the color has completely changed over to the color that you're using. The previous one was gray. Next, we're going to go back to OctoPrint. We're going to click on upload. We're going to choose the G-code file that you saved before. And you should see it pop up in the menu somewhere. It should be in black if you had just uploaded it. We're going to click on the text. You can check that the file is correct. And then after that, you should be able to just click print, and the print should start on its own.